Um, what I will treat today is material balance calculation. This calculation involves calculation in engineering field. It is a process of checking the inflow and outflow of a material in a process. So if you are involving yourself in production, for example, you now calculate the amount of feed you put in, the amount of the materials you put in order for you to produce what you want to produce. So if you calculate the amount of the material that you feed inside your equipment, and when you now have your product, when you finally finished what you are producing, then the product will now come out from your equipment. So you now calculate whether is the amount of what you put in is the amount of what comes out. So that is what brought about material balance calculation, checking inflow and outflow of materials in a process. Maybe you are producing a soap, you gather all the materials, put them in your mixer, and after production you check the quantity that comes out. The same thing in everything you are producing, bread, anything at all, in any company, they do material balance calculation. So this one on board now is material balance on a filter, filtering something. You know, if you want to filter something, you now pour the quantity of the material you want to filter in, and after filtration, you now check the quantity that comes out after filtration, whether it blends with what you feed in. So it is a calculation involving filter in this aspect. And in this aspect now, there is no chemical reaction. This calculation I'm doing involves the one that not involve chemical reaction. It is just checking the mixture. What you put in, is it what comes out? It does not involve chemical reaction. So the question on board says, a slurry containing 40% by mass, 40% by weight of solids is filled into a filter. The filter cake contains 80% solids and the filtrate contains 5% solids. If the feed rate is 5,000 kg per hour, calculate the flow of cake and the filtrate. So that is the question now. You know, in calculation of slurry involves liquid. It involves watery mixture of insoluble matter, such as mud, lime, plaster of Paris. So it involves watery solid. It's just like putting mud in a water and mix it. You know you can filter it. So that is what it involves. Slurry means watery mixture, something that contains water. So now, if the question say a slurry, there's a slurry that is containing water and the solid. So in this question, the weight of the solid is 40%. Look at the diagram of the calculation. So if you want to calculate solution, you now draw your diagram. This is the filter. When you pour the filter, this is the feed. This feed is the material, the mixture you are now pouring on the filter to filter it. So when you pour it now in the filter now, so the filter, the feed rate is 5,000, remember, 5,000. So the feed rate now, the rate at which you are pouring this in the filter is 5,000 kilogram per hour, which means every hour, every 1 hour, you pour 5,000 kilogram of the slurry on a filter in order to filter it. So now, if you pour it now, if you pour this thing, in 1 hour, you have poured 5,000 kilogram on this. Remember that the solid in this mixture now contains 40% solid. There is 40% solid in this mixture. Remember now that you don't, they just mention 40% by weight on the question. So since it contains 40% by weight of the solid, it means the liquid there will be 60. You don't need anybody to tell you that the liquid on that mixture is 60%. So you know it. You don't need the question to tell you that the liquid is 60%. So the percentage of the solid in this mixture now is 40%. So since it is 40% solid in the mixture of the slurry, therefore the liquid in the slurry will be 60%. That is what you will start with. Now you pour it in the filter. Then now you filter it. After filtering the cake is a particle. Those particles you filtered out. That is what we call cake. Those solid you filter out is the cake. So now you filter out now your cake now. The cake you filter is this. So the question say in that your filtrate now, you now have 80%. You now have 85% on your filter. Like after filtering, the solid, the cake now has now 85%. So it means now it has more solid now than the water, because you know you have filtered the water out. So it now contains 85% solid, which means 15% liquid is remaining there. You don't need anybody to tell you that the liquid that is remaining there is 15%, since the cake now is 85%. Another one, then the filtrate now, the water you filtered out, which we call the filtrate now. You now have that in that filtrate, you know, majority of water will go now in your filtrate. So that water now contains only 5% solid. You know, it's majority of water now. So it is now contains only 5% solid in it, thereby now has 95% liquid of water. So when you just state it this way, you now start your calculation. In your calculation, we now have feed equals to W plus P. What you feed in is equals to what comes out. You know, let us state it this way. What you feed in is equals to waste, the one that you will throw away, and the product you will use. You know, after production, there are the one you will throw away, is possible, and there are the one you will use. Or as a process of the production, there's one that will be lost, and there's one that you will get. So that is all waste plus product. So you need to add them, because that will now make up the feed, the one you feed in. So now it is now feed equals to waste plus product. Then in this aspect now, we will take our waste to be water, the filtrate. Then we now take our product to be cake. So now our feed, remember that we have what we call basis. We have what we call basis. In material calculation, you state your basis. So our basis now should be 1 hour. 1 hour. Basis. Our basis should be 1 hour. Why is it 1 hour? It's because every 1 hour we pour 5,000 kilogram of the slurry every 1 hour. So the basis of this production is every 1 hour you pour 5,000. Every 1 hour you pour 5,000. So So our basis now is 1 hour. Now from the calculation now, our feed is 5,000. Remember, we know our feed 5,000 equals to, we never know the feed rate. You know, W represents feed rate, and we never know the amount of cake, which is P. Now let us do component balancing. We can do component balancing with liquid to get what we want, or we can do component balance with solid. So anyone you choose will give you the answer. Okay, let's now do the component balance with the liquid. Now remember, in our liquid, using the liquid, for example, the liquid, you know, we have 60% liquid on this product, 5,000. So now when you 60%, you divide it by 100. Now remember, 60% divide it by 100 before you start calculating. So now if you divide 60% by 1,000, you now get 0.6, right? You now get 0.6. No, so okay, now let me put it this way. You now have 0.6% with feed equals to, in feed rate, remember we are talking about liquid, we are using liquid. Remember, in feed rate, our liquid there is 95%, which is 0.95% of waste, plus product. Our liquid in product is 15%, which is 0.15 product. You understand? That is the component balance with the liquid. Remember, component balance with the liquid. Now we have feed to be 5,000. Now say 0.6 times 5,000 equals to 0.95 W plus 0.15 P. Remember, 1,000 times 0.6, you now have 3,000. We now have what? 3,000. We now have a 3,000 equals to 0.95 W plus 0.15 product, right? So now we can make one of these things subject of formula. Is either we make W subject of formula or we make P subject of formula. The choice depends on you. So now from my own choice, let me make a P. So making P subject of formula, we will now have equals to W plus P. So let me make P subject of formula using this one. Remember, using the main equation. Let me make P subject of formula here using the main equation, which is P. So making P subject of formula here, I will now have P equals to F minus W. That's how to make P subject of formula. And I have P equals to F minus W. Now substituting this value here in this place, this is P here, we have W and P here, so this is P. Since P equals to F minus W, I will now remove this P here and put F minus W. What do we have now? I will now have 3,000, remember, equals to 0.95 W, remember, plus 0.15. Now instead of writing P, I will now exchange it with this value, which is F minus W. Remember. So now open the bracket. I will now open what? The bracket. I will now have a 3,000 equals to 0.95 W plus, if you open the bracket, what you have now is 0.15 F minus 0.1 F W, right? Now collecting like them, this and this goes. I have 3,000 equals to 0.95 W. This one will come here now minus 0.15 W plus 0.15 F. So when you minus now 0.95 minus 0.15, you now have 0.8W plus 0.115 times F. Remember, our F is 5,000. Remember, our F is 5,000. So we now remove this thing and put our 5,000. One say 5,000. Now you multiply 1 times 5, 0.15 times 5,000. We now have 750. We now have what? 750. Now we now have a 3,000 equals to 0.W plus 750. Remember, now collecting like terms, this will come here. Remember, this is 0.8. Remember, now collecting like terms, so now have a 3,000 minus 750 equals to 0.8W, right? So when you subtract 3,000 minus 750, 3,000 minus 750, you now have 2,250 equals to 0.8W, making W subject of formula. Now have W equals to 2,250 all over 0.8. When you divide 2,250 divided by 0.8, you now have 2,812.5 kilogram. Remember, let me write the way you will see it. Now have 2,812.5 kilogram per hour for W. So you have gotten the value of W. I've gotten the value of W. Now let us now get the value of P now in a simple way. So remember that we have before, we have F equals to W plus P, and the F is what? 5,000 equals to W, which is now 2,812.5 plus P. So making P subject of formula now, we now have 5,000 minus 2,812.5. So when you say 5,000 minus 2,812.5, we now have P, our P now will now be 2,187.5 kilogram per hour. The flow of cake. So the flow of cake, which is this one now, is which our P. You know, cake represent our P. Is now the flow of it is now 2,187.5 kilogram per hour. Then he also say we should calculate the feed rate. So we should calculate the feed rate, calculate the flow of cake and the flow of feed rate. So now the flow of feed rate now, which is our W, is 2,812.5 kilogram per hour. So this is how to calculate it. You can, I remember I said that you can use the component balancing to do it. You can use the component balancing of the liquid. If I use now the solid, if I still used the component balance of the solid, which is 40%, I will use all of them. I will use 40% here for feed, use 5% here for feed rate, and use 85% here for cake. It will still give us the same value. You can try it with this method. You know, I use the liquid component balancing. So if you like, you use a solid component balancing. you will still get the same answer. Please try to subscribe. Don't forget to subscribe on my YouTube. Subscribe and like. And I have an account on Facebook, which the name is Chewumba Power. So you go there and follow. Thank you so much for watching.